Hello, everyone. Thanks for joining us today. My name is Brian Turf. I'm a Senior Director of Product Marketing at EDB, and I'll be your host for today's webinar. Before we get started, I wanted to just review a couple of housekeeping items. First, the presentation is being recorded, and we will share the recording along with slides after the broadcast, so please keep an eye out for that email this week. And secondly, please note that all lines are currently muted, so we can't speak to you directly, but we expect the presentation to be between 30 and 40 minutes, and we will have plenty of time afterwards for Q&A. If you do have a question, we ask you to enter it into the Q&A panel instead of the chat box, as I'll mostly be monitoring the Q&A panel. If you do put it in the chat box, I'll try to get that in as well, but it's much easier if you put all questions in that Q&A panel. And that's about it. If you have any technical issues, I think you can handle that through chat. And with that, I'll hand it off to Adam to kick us off.
All right, thanks, Brian. Does my slide look good? EPAS15, the most secure Postgres.
It's up.
All right, great. Thank you. Hello, everyone. As you can see, you're in the webinar titled EPAS15, the most secure Postgres. This webinar is about today's EDB Postgres Advanced Server 15 release. And the headline feature, Transparent Data Encryption. In today's webinar, we will also highlight other aspects of the release and talk about some of the new features available for Oracle users when running EPAS in optional Redwood mode. All right, let's jump into it. My name is Adam Wright. I'm a senior product manager here at EDB, responsible for the database server, database extensions, and backup and recovery tools. I advocate on behalf of EDB customers for the features they need to run Postgres successfully for the most mission-critical applications. At EDB, we hear from a lot of customers, a lot of DBAs, a lot of developers about how much they love Postgres. But if there's something that's missing, that's holding your company back from running Postgres to support every application, we want to know what that feature is. So prior to focusing on the core database, I worked on EDB's container and Kubernetes solutions. And prior to that, I was a database consultant, working hands-on with anything and everything related to Postgres and EDB tools. Today's agenda is pretty straightforward. This morning, EPAS15 went live on EDB software repositories. The documentation is available in EDB docs, and we're going to highlight key features of the release. I'll cover the headline feature, Transparent Data Encryption, in great detail. V15 was also a huge release for Oracle compatibility features. We'll highlight those features as well. You know, if you're migrating from Oracle, the amount of manual rewrites that you need to do has likely been significantly reduced. Or if you just want to continue to use your Oracle skills, many more of the Oracle functions that you're familiar with will be in this release. So EPAS is a superset of community PostgreSQL. In years past, we merged EPAS with the upstream community project and released a new major version of EPAS with the first quarterly community patch. This year, we pushed V15 back until the second community patch release, which was just last Wednesday. And we did that in order to add transparent data encryption to this release. TDE has been one of the most requested features from EDB customers, but getting TDE into Advanced Server properly required patches in the upstream project, but this was the right time to do it. And we're very, very excited about the implementation. If you're running in Redwood mode, which includes Oracle compatibility in Advanced Server, we're taking the first steps towards making the brand new merge command and community PostgreSQL more compatible with Oracle's when using EPAS. Also, V15 has new SQL syntax support and expanded coverage for existing Oracle packages. So I think we support over 10 new functions from Oracle. And one part of these releases as well is making sure that our customers can use all EDB supported tools with EDB Postgres Advanced Server. So you can be sure that your favorite tools, your favorite extensions from EDB have been tested and are certified for EPAS15. And this also includes installers for supported operating systems. So we try to avoid any cases of, well, this package is available on RHEL 8, but it's not available on Ubuntu or SLES. All right, so just recapping real quick. So on PostgreSQL, for PostgreSQL 15, it was released on October 22nd by the Postgres community. Once again, EDB staff were major contributors to this release, helping with some of the headline features that you see here, the merge SQL statement, along with contributions to new logical replication enhancements and improvements to backup and recovery capabilities with new compression options, LZ4, Z standard, along with server-side compression. You can find plenty of community resources about the PostgreSQL 15 release. You can also check out EDB blogs and webinars that we did around the time of the release. All right, for today, we're going to focus a good portion of the webinar on transparent data encryption. It's a huge capability that EDB customers have been demanding for quite a while. More and more of our customers are storing their most sensitive data in Postgres. Postgres is getting really popular in heavily regulated industries. So this is a direct response to those requirements. So cybersecurity has the concept of defense in depth. It's a layering approach to security. At any given point in time, there's likely to be a vulnerability or breach in one layer. So there's a 7-layer framework that is common in cybersecurity circles. And one of those layers is data security. But within data security, there are multiple layers. The data layer that we have an obligation to protect is Postgres. At its most basic level, Postgres consists of a Unix process and a bunch of files on disk. It's slightly more than that. The main Postmaster process have child processes and there's shared memory, private memory. But the two main attack vectors are the processes communicating over a database communication and the disk reading and writing. You authenticate through the Postgres parent process, and if successful, you fork your own process, and catalog tables stored on disk have the rules that determine what you can and cannot see. Those items are protected on disk with operating system file permissions, and most current protections in Postgres deal with that process layer. With PostgreSQL, you can control which network interfaces Postgres listens on through the listen addresses parameter. You can control where a database connection can be made from through PGHBA rules. Only allow connections to my app database from application server IP addresses. But you can also control who can connect. So you can take that one step further and say, only allow connections from the app user from the app database, from the application server IP address to that app database. So members of the PostgreSQL DBA group, you can restrict their connections to only come through a jump server IP address. And then once those connections are made, PostgreSQL controls which databases you have access to, which tables you have access to, which schemas you have access to. Even you get down to column level permissions, only restricting access to a table through a view, a table return function. There are a lot of data access controls in PostgreSQL, even row level permissions. So you can restrict which rows are returned to a given user. This is really helpful. There's been plenty of cases in the news of like stalking and domestic violence where someone misused their access to a database to see personal details that they had no business purpose to see. EDB Postgres Advanced Server even adds data redaction, which can redact portions of a single column value, like the last 4 digits of your social security number. And then there's proactive protection. If your application is exposed, hackers can manipulate the application into sending a query back to the database server that was not intended to be sent. In this case, EDB Postgres Advanced Server provides an extra layer of security with SQL Protect by proactively blocking queries that match common types of SQL injection attacks, such as tautology, where the condition is always going to be true. All the rows are always returned. You also have unbounded data manipulation statements, something like a where clause. So set the balances equal to 0 and not include a where clause. So that's going to update every row in that table. these can be blocked with SQL Protect. Logging and alerting, Postgres has a great logging system. EDB adds auditing capabilities to the database server in the form of EDB audit. And that is really easy to integrate with your enterprise SIEM. All right, so quickly, here's a list of the security and features in EPAS that I just discussed. These are in addition to great features already available in Community Postgres. But I mentioned earlier that at a basic level, you have a process and you have a bunch of files on disk. The feature in those two previous slides address going through that process layer. But what about the storage layer? In Postgres, relations, meaning tables and indexes, are stored as files on disk. You create a new table, a new file on disk is created with the table's unique object ID as its name, and then as data is added, it's inserted into that table, written to that file on disk, and then once the 1 GB limit is exceeded, a new table is created, and then data continues to be written. So if we look at the graphic on the left-hand side, we have a table, tbfoo, that exists in the database, and we insert two character values into the table, the values ABC and 123, and we insert those as a string. Using a function in Postgres that shows where on disk the data is stored by relation name, I can see that the table is stored under the base directory in PG data. The database has a unique ID of 5, and the table name apparently has an ID of 16416. On the right-hand side, we are bypassing Postgres altogether and using operating system tools to get at the data files. So this could be an insider threat, a system administrator, or a hacker that found a vulnerability at the operating system level. Most Unix systems include a hex dump utility to view the contents of binary files. So it's actually, and if we look at this example here on the screen on the right-hand side, the output of the hex dump utility, on one side, we have address plus the data in hexadecimal form, and on the right is human readable text. So we can see on the right-hand side that the values of the row are ABC 123. Again, this is bypassing the Postgres layer. So what's really missing is security at the storage layer. So a concept that you're likely familiar with nowadays is that of a personal password key vault. And it often requires two pieces of information to read your passwords. So what we did is something very similar for Postgres. So what if we scrambled the data in those files in a way that it can't be reconstructed by another person using a strong algorithm like AES 128-bit encryption? And now you need access to two pieces of, you actually need access to the data blocks on disk, and you need a second piece of information. You need a key to make those data blocks human readable. And that's what data encryption is. With transparent data encryption, when Postgres starts, an external key is required, and then application users going through the Postgres process access the data like they normally would. The key is the second piece of information that's needed. Once the database starts and connections are made, all of those other security protections that we talked about, they're now in place. So database level permissions, table level permissions, column permissions, row level permissions, those all take effect afterwards. So there are really two keys. There's the database encryption key stored next to Postgres, and there's the remote key to unwrap the database key. So now storage with TDE. So on a cluster with the new TDE enabled, we can go through the same exercise as before. We have a table named tbfoo. We insert two strings into the tbfoo table, ABC and 123. And like the last example, these are screenshots from a test that I did. I ran through the exercise immediately after initializing the cluster. So the data file on disk is once again 16416. And with access to the operating system, I navigate to PG data base database 5 and use the hex dump utility to view the binary data of our Postgres data file. Using AES encryption, the data has gone through several rounds of permutations and character substitutions. And now the data on disk contains none of the strings that we inserted into the table. There's a lot of characters visible, but none of that can be pieced together without the master encryption key. If someone gets access to the operating system, the data in Postgres is protected. If you send your backup to a NAS device, storage device, or to a public cloud object store, that data is still protected. You will always need access to that master key in order to start Postgres or just view the data unencrypted. All right, so a high-level overview. So finding a buyer for your organization's data is not difficult. The internet has made that relatively easy and anonymous. So this expands the list of threats to also include internal staff. And most, if not all internal staff, have no business case for reading data from your application tables. Really, the content of those tables should only be visible through valid business applications. And TDE is the tool to prevent unauthorized viewing of Postgres data by system administrators who can bypass database protections and view the database and view the data files at the operating system level. And since with EDB's TDE solution, the blocks on disk are always encrypted, this again, it expands to backups. So if you're, no matter if your backups are local, they'll be encrypted. If your backups are remote, they'll be encrypted, even in other data centers. This is important because once your data goes to a backup location, you get an entirely new set of administrators that gain access to those files. Typically there's at large companies, there's backup system administrators. Also, when your data goes somewhere else, you get a new set of network access points that malicious actors can start to try and exploit. And Postgres has had column level encryption for quite a while. This has been in the form of PG crypto. EDB also has DBMS crypto in Advanced Server as part of the Oracle compatibility layer. And column level encryption, it's still critical for many sensitive columns, but the current implementation is not transparent. Which makes application adoption low because the applications have to then be modified by wrapping column calls with encrypt and decrypt functions. With transparent encryption, the call to the external key management system is made by Postgres, and Postgres applications behave the same way with non-TDE and TDE systems. So flexible key management architecture. So EDB's solution has a flexible key management implementation. In other database systems, this is referred to as extensible key management. This means that the database encryption is close to the database, but the master key itself is stored on a separate system, and you can inject any logic that you want to access that master key. All right, so here's the high-level architecture. So on the bottom left, we have the data blocks on disk, and at the lowest level, they're 8K pages. Those pages include some internal metadata and row data, also referred to as tuples in Postgres, and all of that data is encrypted. You can see on the lower right-hand side that the data is totally unintelligible, because it's at the storage layer. We also have the write-ahead log, which in Postgres ensures durability. If you come from other database systems, this is analogous to Oracle's redo log, also analogous to Microsoft SQL Server's transaction log. So data is stored in the wall buffers, unencrypted. When a user issues a commit, then Postgres issues an fsync to write the transaction record to the write-ahead log. This is the point at which Postgres encrypts the data. And when Postgres users are accessing the system, running queries, doing large sorts, large hashes, and that data is in private memory and it spills over to disk, that data is also going to be encrypted. So all user data is going to be encrypted if it lands on disk. And when you're writing new records to Postgres and that data is stored in shared buffers as a dirty buffer, that data is unencrypted at that point. And then the data is eventually written to a disk with something called a checkpoint. This is at the point where the stable data file or the data is written to stable data files. And at that point, the data is encrypted. And for as long as I can remember, PostgreSQL has supported SSL communication between the PostgreSQL server and remote clients. TDE does not automatically encrypt data in transit between the client and server. So you need to make sure that host SSL is enabled. This is a best practice anyways. It's well documented in the Postgres community, very easy to set up. Nearly all Postgres drivers default to attempting an SSL connection first. You can also set up your pghba.conf file to only accept SSL connections so that an application can't bypass SSL and send queries across the wire unprotected. So that's basically it. Recapping, TDE includes two keys: the database key generated and managed by Postgres that encrypts data and decrypts data. And then there's the master key you first set up that encrypts the database key. From there, Postgres will automatically decrypt data before it arrives in shared buffers and encrypt the data when it's written to disk. All right, so what exactly is encrypted? So basically, again, if you're inserting row into the database, any copy of that row is going to be encrypted, whether it's in a persistent state or it's in a working state. You don't need to worry about ensuring that the data fits in an AK page or fits perfectly into your private working memory area. If it hits the disk, it's going to be encrypted. Stepping back just a little bit, it's important to note that the EDB architecture encrypts the entire cluster. So TDE's implementation is not table space level encryption. We evaluated the pitfalls of existing TDE implementations. And besides the location of encryption keys, ghost copies of sensitive data was the #1 issue that was cited by users of existing TDE implementations. In Postgres, you have to be explicit about which table space a relation is stored in. Otherwise, it's going to go to default. If you encrypt a table space, it's easy for one piece of application software to generate a new schema, generate a new object, or any piece of DDL that's going to omit the encrypted table space. In production, it's not uncommon for copies of data to be moved around in the same system. Anyone who's spent much time in database operations has seen this. Indexes can also be stored in their own table space. So again, the EDB implementation of TDE encrypts the entire cluster, Postgres system catalog tables, and your application data. So what is not encrypted? Outside of the Postgres data files, there's metadata internal to database operations where user data is never stored. So this is your PG data directory, not at the base, within the base folder. So this would be transaction metadata, for example. What's the transaction ID for the parent ID and the child query ID? And that information contains no user data, and it's also obsolete once a transaction completes. That data is unencrypted. If you have access to the operating system, you could gain some structural information about the system. You could find out the number of databases by looking under the base directory. There's a separate folder for each database. Within each database folder, there's at least one separate file for each relation. You could run some operating system commands to figure out how many relations exist in each database. If you use foreign data wrappers, the remote table is not encrypted unless that cluster was also initialized with TDE. So the two systems are independent of one another. Server diagnostic logs and configuration files are also not encrypted. So in short, user data is always encrypted. Some metadata needed for Postgres operations by the Postgres system are unencrypted. All right, tested and supported key stores. So TDE uses a double encryption system. A database encryption key is generated by Postgres. It has to be encrypted. And if you want that, you want that key to be separate from the database server. For non-critical systems, you could use a passphrase, but for serious mission critical systems storing sensitive information, you're gonna want to use a robust key management system. So the EDB implementation of TDE has a flexible architecture for master key management. You might be familiar with the term extensible key management. That's essentially what we're talking about here. We provide a hook to encrypt the database key, PG data key wrap, and hooks to decrypt the database key, PG data key unwrap. So when you initialize a new database with the initdb command, you're doing a wrap. When you're starting PostgreSQL up, then you're doing a data key unwrap. So you can use any key management system without requiring EDB to make updates to the server code. The best analogy that I can think of with this would be the archive command. A WAL file is full and switched, and a shell command is executed that could essentially do anything that you can code. That's the same thing here with the wrap and the unwrap command. You could inject a passphrase, you could call an external key management system. So the key management systems listed here, the ones that we have tested so far. We'll add testing for more key management systems based on your feedback. If your enterprise key management system is not listed here, please let us know. But many large organizations do have key management systems, and those key management systems provide integrate features like auditing, network restrictions, soft deletion. And with public cloud implementations, everyone now has access to enterprise grade key management solutions through those big public cloud providers. So if you're running an Amazon AWS, Google Cloud, or Microsoft Azure, you could use the native key management solutions in that environment. They're also publicly available, so you can reach them from your own internal data center. We're seeing a lot more of these hybrid solutions in other areas, such as like database backups. And on the right column, we have Oasis KMEP. This is a standard protocol, and EDB has partnered with Thales for several years for a non-database native TDE solution. And we're also partnered with them for Thales Cipher Trust Manager. So with our native TDE solution, we've developed a KMEP client that is tested and certified with Thales Cipher Trust Manager. All right, so here's the details of how this works in practice. What's the most straightforward way to implement TDE? Well, you just encrypt the database files and start the database server and have Postgres encrypt and decrypt automatically. But once the database server is started, an attacker only needs to take the files somewhere else and go through the Postgres process to dump the data out, using copy commands or PG dump. That's not zero level of protection, but it's not much more than that either. But you could extend that a little further and say, well, provide me with a passphrase. And that would give you some level of protection greater than the previous example. You have to have some information. You have to know the passphrase. This presents a couple of problems in practice. Once you have to provide that password when the database server starts up. So operationally speaking, that's pretty difficult. You also have to remember the passphrase itself, and if it's a human that's actually entering that passphrase, how many random characters you can remember. 5 is probably pretty easy. 10 random numbers is doable for most people, but 13 or more random characters, and it starts to be difficult to remember. And the shorter the passphrase, so the problem is the shorter the passphrase, the shorter amount of time it takes for others to guess, or the shorter amount of time it takes for a computer program to iterate through all the possible combinations. So they could just increment through all possible combinations and increase the length. And if you're doing a dictionary word, it only takes a few minutes for a modern computer to go through all dictionary possibilities. But that option does exist. You can go through, write a simple program, read the passphrase on disk, print it to standard output. But then you have to protect that file, which resides on the same system. And then you have to know if the file was accessed, which you could do with Linux Audit D. Then you could have some version history and have backups for the file. But there are sophisticated programs out there that specialize in protecting those key files that can be used to unlock sensitive doors. And those are key management systems. So I mentioned on the previous slide about the number of random characters most people can remember is too short. And many people nowadays, they use a password manager. And with a password manager, you don't need to remember multiple passwords or even remember the password itself. So you make each password random and you make it much longer than you would otherwise. And those passwords are stored somewhere like a vault. And you need some other form of validation or some combination of things to access the vault, like a passphrase, access to a mobile phone associated with the vault. So these enterprise key management systems do something very similar. They can keep an extremely long key an extremely long random key and make it that is uncrackable by modern computers. And you can restrict access to the key in a vault with things like your cloud identity account or a service account. And you can start to do things like include region-based restrictions. These key management services also address much of the complexity that I highlighted earlier, like audit monitoring, rule-based alerting. It would be nice to get a notification. Hey, was this key accessed outside the time when the database server was starting? Do you want the key available in one region, or do you want the key available in multi-regions? There's a lot more advanced features in these key management systems that you don't need to code yourself. So this example on the screen, it's using Amazon's key management service. On the left-hand side, we're using that key to encrypt the database key when we initialize a brand new EPAS cluster. And we do this using AWS APIs. And on the right side, we have a command which calls the AWS key management system to get the master key, which unlocks the database key. The fact here that it's AWS is not really the main point. This could be something very similar for Google or Microsoft's key management system as well. We could have slides for each one and they'd all look pretty similar. And you could also see examples of those in EDB docs. To further highlight the extensibility and directly address customers who are in need of OASIS KMIP compliance, you can see that the wrap and key unwrap command call a Python-based KMIP client to communicate with Tali Cipher Trust Manager. This is a supported and tested configuration and is really highlighting here the flexibility of EDB's TDE implementation. All right, and there's another way to wrap the database and encryption key, and that is when you deploy in Kubernetes. And so EDB's Kubernetes solution is cloud native PG based. It's EDB Postgres for Kubernetes. Deploying in Kubernetes gives you an additional option of using native Kubernetes secrets. This is an especially great option for like dev and test systems, and TDE is handled declaratively and managed by the Kubernetes operator. You can create a secret with a long string. It's only base 64 encoded, and you reference the secret in your Postgres spec on the bottom side. The operator will then handle wrapping and unwrapping the key. You then need to be careful about RBAC rules with the secret and ensure that access to your etcd cluster is secured, since the base 64 value will be stored there by Kubernetes. One of the really cool things here is that the implementation of EDB Postgres for Kubernetes, or TDE with EDB Postgres for Kubernetes, didn't require any updates to the EDB TDE solution at all. They were just able to use the architecture was flexible enough where they were able to just plug it into the operator. All right, so I'm going to go ahead and do a demo here. All right, so I'm going to go ahead and I'm going to use Kubernetes as an example here. So I have my TDE key. This has a long string, so this is a Kubernetes secret. So this could be very analogous to like an external key management system. And then I'm going to look at my Postgres spec. And EDB Postgres for Kubernetes is declarative. And we can see in the spec, we have the TDE key, and then EDB Postgres for Kubernetes is going to go ahead and with the netDB, is going to call the option to encrypt the key using that secret. So I'm going to do a new deployment. All right, so now my cluster is starting up here. All right, so now I'm connected to my cluster via bash. And if I go to PG control data, and I'm going to grep on encryption, I can see that data encryption is enabled. If this were 0, TDE would not be enabled. And I'm just gonna go to PSQL. I'm gonna do the same example from before. So I'm gonna create table tbfoo. We'll just do one column here. Insert into tb2, tbfoo A. We just do values. All right, so we've inserted 2 rows. I mentioned earlier that the data is not encrypted until it's actually written to disk. So right now the data is in shared buffers. It's a dirty buffer. So I need to issue a checkpoint for it to be written to disk. And now I'm gonna find out where the file lives on disk. All right, so it's in the base directory. Database OID is 5 and 16387. Just going to go to PG data, base, and we can see here that this data is scrambled. There's not going to be a value for EDB or a value for ABC. Slides took a little bit longer than I was expecting earlier. You have to trust me if you want to go through this exercise in yourself. If you were to do this on a cluster that is not encrypted and went through this exercise, then you would get the values ABC, you would get the values of EDB. You would also see a lot less information here, and that's because with the encryption process and the files written on disk, we're actually filling in that blanks. The encryption algorithm is actually filling in that blank space. So with XTS and AES, the data files themselves are not bigger, but a lot of the free space is going to be filled in. So you're going to see a lot more data when you actually look at the binary data on disk. If I were to take a backup here and pull that backup down, something like Azure blob storage, which I had set up, running a little bit lower on time than I was expecting, then you would also pull that data down, and it's going to be encrypted no matter where you are. So this is a very simple exercise. It's just using EDB Postgres for Kubernetes to highlight, the implementation is very flexible. It's easy to deploy, but even if you just did an install yourself, went to EDB repositories, installed EPAS15, initialized a new database, passed the -y option, encrypted the data, ran through the same exercise, it's going to be exactly the same. If you were to omit the encryption option, run through the same exercise, you're going to see your data files on disk in a human readable format. And then if you push the backup to an object store or to anywhere you want to, you're going to have the master encryption key to be able to unlock those data files. You're not going to be able to see the plain text data. It doesn't matter if it's on your own system, doesn't matter if it's on a remote system. All right, so I'm going to jump back into the slides here. I'm going to run through this. I can see up top, there's a lot of Q&A, so I want to make sure we leave enough room for Q&A. So I want to hit the Oracle compatibility features here as well. All right, so we'll get into the Oracle compatibility portion of this webinar. So EDB has 3 database distributions with 3 corresponding subscription plans, and each one of those is Postgres focused. If you want to run community PostgreSQL and use only open source tools, but want support from the Postgres experts, we will enthusiastically support you with Community 360. But if your organization has additional requirements and can't wait for community features like TDE to be added, then EDB has an extended version of Postgres in the standard plan. This also includes additional EDB tools and advanced logical replication. Features needed for the logical replication features are needed for the most advanced features in EDB Postgres distributed. For our enterprise subscription plan, there's EDB Postgres Advanced Server, which adds many new features on top of PostgreSQL. And EPAS itself can be initialized in one of two modes. There's Redwood mode, Oracle, Redwood/Oracle mode, or you can do it in Postgres mode, something we've been referring to as Berkeley. All of the major features are available in both modes, but Redwood mode contains additional Oracle packages and also defaults to Oracle-style date and time behavior. In either mode, you can use advanced SQL, like Oracle-style packages, autonomous transactions, interval partitioning, or you could just use Postgres features and enable the features that don't affect your application, things like TDE. But if you're migrating from Oracle, you want to reuse your Oracle development patterns, then Redwood mode includes a large number of Oracle functions, views, DBMS, util packages. EDB has been adding Oracle features to EPAS for over 15 years now. And we have most of the major features from Oracle. We're extending that list, but focusing on syntaxes that are most often seen in our migration portal, and these are really those syntaxes that require migration customers to do manual rewrites. We want to reduce manual rewrites to as close to zero as we can get to. And two of those packages that were frequently encountered in the migration portal were HTTP and HTF packages. And those two packages require major rewrites if you were migrating from Oracle to EDB Postgres Advanced Server. The business logic either really needed to be moved to the application layer, or you needed to use a procedural language in the database like PL Python. Prior to EPAS15, if you generate HTML tags in the database, especially with legacy Oracle systems, you now have the option to migrate to a Postgres system with minimal rewrites. Prior to V15, EPAS supported 15 subprograms of the DBMS utility package. Now EPAS supports 17 subprograms. We added support for format error backtrace and format error stack. These two programs are very useful for debugging purposes. If you're putting a lot of complex business logic inside the database, you can leverage these sub programs and you can get a backtrace or an exception name in a readable format. A lot of Oracle DBAs said this is important to them. We hit it many times in the migration portal, and it's now in Advanced Server starting today. Again, most of the development work in the area of Oracle compatibility is driven by syntaxes we encounter most frequently and those that still require manual rewrites. You can see on the slide that the additional SQL and functions that have been added, and you can see the additional functions that have been added in V15. It's important to note, though, that differences in behavior for community PostgreSQL and Oracle can go deep. So even when community Postgres adds a SQL standard package that exists in another database system, that doesn't mean you can just copy the code over and have an easy migration. If you have much logic in the database and there are other tools that have a nice fancy interface but do regex under the hood, you might see a high success rate in getting those objects converted, but things really start to fall apart when your application starts calling those stored procedures. Advanced Server does not use regex. Advanced features are baked directly into the database core, and this is done by developers who also contribute to community PostgreSQL. Merge syntax is a great example of this. EDB staff were the primary contributors to the feature in community PostgreSQL, but because of the behavior differences between the two systems, and contrary to many blog posts, you can't just assume that a merge statement that works in Oracle will work in PostgreSQL. You can't just copy that code over, paste it to PostgreSQL, and move on. Migration's done. So this is a perfect area that EDB can help close the gap with for our customers migrating from Oracle, with some additional Oracle syntaxes. So with V15, we specifically supported a where clause in the to merge in EPAS. And then V16 in fall 23 will extend merge even further. So I'll quickly highlight this. Pull up another terminal window. I'm gonna cat merge, DDL, merge, DML. All right, so I have create table, city source, create table, city target. This is very similar to many of the examples that you're gonna find online for the merge statement. And you can see there's just some slight differences in the characters between uppercase and lowercase. So I'm gonna log into Oracle. And I'm gonna create my table, city source. Create my table, city target. And populate those rows. Do select star from. Oh, sorry here. Insert into Washington. Oh. And we can see Boston, Massachusetts. Boston is lowercase. The B in Boston is lowercase. The state code MA is also lowercase. So I'm just going to do a pretty standard merge statement. It's just going to make sure that the rows from the source table and the rows from the target table match. Star from city target. All right, so now our city target table matches the city source table. Now I'm going to copy and paste this code into EDB Postgres Advanced Server. And select star from city target. So we can see our merge statement was successful. We have a B, we have an MA. So merge is there. I'm going to go ahead and apply. I'm going to create a new PostgreSQL community cluster. This will just take a minute. There's an HA in there. Okay. See if it's up and running now. All right, so a lot of our syntax does not work there. Oh, that's because we have a varchar 2. So my temp SQL, do I have this already? Okay. I'm gonna replace varchar 2 with a regular varchar.
Yeah, too many A's in the first varchar.
Okay, thank you. So varchar, search. This is a live demo. And my typing's not so great here on a webinar, but I think we're gonna make it through. All right, there we go. Get rid of the lines, cat. All right, so we're gonna create our tables with community PostgreSQL. Select version just to show. So PostgreSQL. All right, all of our rows are there. So select star from city target. Oh, sorry, another typo. Boston, and now we should be able to use our merge statement from before because PostgreSQL now has merge. Sorry, that was the wrong one here. And you can see that there's some subtle differences in PostgreSQL, right? So this one is table alias, but there's some different behaviors, things like where clause, delete clauses, where the behavior is going to be different in, between the two systems. So that's not to say merge isn't a great, great feature that's in PostgreSQL, but it does show, how deep the behavioral differences between the system are, and how a lot of these advanced features really need to be put into the database core to be able to do a successful migration. Because this is a good, easy case because, hey, we can see that this just didn't work. The worst case is everything looks like it works, but the actual differences on the back end where a row update was different between the two systems. So it was successful, but the actual behavior was different. That's the more dangerous case. Sped through the last of those demos here, but we got through it. There's a lot of Q&A, so I'm going to stop sharing for now and take a look at the questions that came in. Thank you. Well, 1 second before I do that, sorry. I got 2 slides I want to do real quick. EDB docs went live this morning with V15 updates. You can get a lot of detailed information about the features that we talked about, including transparent data encryption. So if you want operationally, how do we actually implement this thing? Covered in great detail, a lot of the considerations that you need to be aware of. And also EDB Postgres Vision, our annual conference is going to be in Las Vegas this year, May 9th through May 11th. You come out and talk to a lot of EDB staff, including the people who actually develop these features. So I think that's it. Let's open it up for Q&A.
Yeah, and just as a note, I put a link to the registration page for Postgres Vision in the chat box. So if you want to get in early, please do that. Let's look at Q&A. I will remind people again, if you have questions, please put them in the Q&A panel, not the chat, because we're going to be monitoring that. And with that said, let's try to get through as many of these as we can. Which version of Postgres is TDE available on? I'll let you answer that. I know it's not exactly straightforward, but.
Yep. So TDE is available in V15 of the 2 database distributions that EDB has. So EDB Postgres Advanced Server 15, TDE is available starting in that version. And then also we have EDB Postgres Extended, which is a minimal addition to PostgreSQL that is used for EDB Postgres Distributed. So you could get TDE in either of those distributions, but V15 is the first major release. We could backport the code, but you would have to go through the same process as a major upgrade because the data has to be encrypted. So V15, and it also required changes in the upstream project that I'm not sure how far back those changes go to.
All right, I had a couple questions around size, kind of pre and post TDE. So I'll just give one of the questions. Are TDE enabled relation files larger than the generic heap storage files?
So we're using XTS, AES XTS. So it's the binary files and disk. You could look that up if you want the actual implementation details. So free space is going to be overwritten. So when you actually look at the binary files, it's going to look like there's a lot more going on there. But as far as the actual size, the binary files on disk are going to be the same size. That doesn't change. And I just happened to glance and see there's a question about files that are larger. I assume talking about toast tables, and those are also encrypted.
A couple people asked this question. I'm not sure if you covered it, but just to clarify, since several people asked, where is the master key stored?
So this goes back to that extensible key management that we were talking about. There's 2 keys. There's the database encryption key that is stored next to the database server. The master encryption key can be stored wherever you want it to be stored. So that's where we had the flexibility. So that could be our decision at EDB was to integrate with your infrastructure. So if you have if you have an existing key management system, we can easily integrate that. There's just a couple of commands that we have to update as long as it has standard APIs. So that master key system, we're not forcing you to use our key management system. We're trying to integrate with your infrastructure. So that should be anywhere that you want it to be. We cover in the docs the big 3, Amazon, Microsoft, Google, their key management systems, and also Tali Cipher Trust Manager. yeah, just contact your account rep if one of the key management systems that you use is not on that list.
Are archived WAL files also encrypted by the TDE mechanism?
Yes, that they are. So yeah, the full base backup is encrypted. The WAL files are also encrypted. So your backups, point in time recovery, all of that's going to be encrypted, which raises another important point that you need to make sure that your master key is also backed up as well. A lot of the key management systems will have like a soft delete process. So if you're keeping like 7 years worth of backups, you need to make sure that your keys from that historic period are also backed up or have a soft delete that extends to the life of your backups.
It's somewhat related to this. Does streaming replication, logical replication still work when TDE is enabled, given that WALs are encrypted? I would assume that WAL streams are as well.
Yep. The WAL stream between yes. So physical backups, physical streaming replication, that's unaffected. The primary and the standby are going to have the same encryption keys. That master key also needs to be accessible from the to the standby server. Logical replication works in the same way, but your logical replication tables, you need to have, if you want that data to remain encrypted, then the subscriber of the logical replication publication needs to also have TDE enabled. You can get into some interesting patterns, where the subscriber has a different encryption key. Maybe it's in a different region. Maybe there's some locality things there. So you do get into some interesting architectural implementations that you could do with that, but yeah, but logical replication, you need to make sure that the target is TDE enabled. Physical replication, it's always going to be encrypted on disk.
How does TDE compare to cloud vendors' disk-based encryption with or without a customer supplied encryption key?
How does TDE compare to a cloud vendor's disk-based encryption with or without a customer's supplied encryption key? Yeah, so in the TDE implementation, we can't automatically generate a master key on your behalf. We do have some guidance to how you could use like a passphrase or something like that. But in our case, something that's a little bit different is no matter where that data goes, it's going to be encrypted. So if you take things like say like an S3 backup and you have like S3 encryption enabled, if that data comes off, a key's leaked and it goes somewhere else, it's a little bit different. So there's some implementation details depending on where you're getting, but it's all fairly low level implementations. Some customers that we've talked to prefer the TDE implementation because that's what they've been using, especially for like compliance purposes. That's what they're comfortable with. So especially if coming from Oracle or SQL Server. So you have the option for both, right? You can use cloud-based disk encryption. You can use the TDE encryption. You can kind of read about what the low-level detail differences are there, but you have the choice for either.
Any big performance changes using TDE versus not?
Yeah, so we're going to have a little bit more guidance to be provided on this. Our benchmarking details so far have been really great. They've actually been lower than some of the standard AES benchmarking that you can find on the internet. On a very busy system with about 200 GB using HammerDB, we've observed about an 8% hit. So you can always expect that the encryption overhead is going to be greater than 0, but what we've evaluated on large scale testing is that the hit is single digits. Doesn't mean your mileage might not vary in some special use case where it's going to be higher, but so far, again, single digit performance overhead or throughput overhead.
We're getting close on time, so I did want to ask a couple of questions that are outside of TDE, but regarding merge, is a couple people have been, I guess in the past used updatable CTE as kind of a workaround. Is merge a more performant solution to that?
I don't know if it's more performant or not. It's a good question. We'll have to follow up on that one. I don't know the answer to that. It's certainly a lot. The code itself is a lot cleaner. If you compare the two, one looks a lot cleaner, is a lot easy for somebody coming behind you to observe. It's also something that's used in other database systems. So even though there's some behavioral differences, if you're used to Oracle, used to SQL Server, the merge statement is going to be very easy to follow. Or an updatable CT, maybe not so much. Performance overhead, I don't know the answer to that.
Someone asked what the official release date for EPAS15 is. That's today. So it was released this morning. I think all the packages are available by now. Go to the website and have at it. I think we're out of time. There's several other great questions here. So apologies that we can't hit all of them. I would encourage everybody, if you had a question that we couldn't answer, please go to edb.com/contact and you can ask a question there. We'll follow up. If you ask a question and we were able to, and you used your name, we'll try to reach out to you and answer those questions. So thank you for all the great questions. Thank you for joining us today. And again, we will share the recording along with a PDF of the slides as soon as we can. So you are able to share that with your teammates and enjoy this later on as well. We hope you have a great rest of your day. And thanks again for joining. Take care.
Thank you.